So what we are looking at here is using trig functions to solve right triangles. Basically, solving right triangles is when you are solving for a given side, like this one, given an angle and another side. You can also solve triangles by given two sides and have to find the angle. So I'll show how to do that right now. But I wanted to show this problem because that's the idea of using trig functions, is finding lengths using angles. So the first thing you need to know is how to use our trig functions. I've gone over this before, but here are our trig functions: sine, cosine, and tangent. And all they are ratios of sides of a right triangle. So basically, in every right triangle, you have a hypotenuse. So if I look at this triangle below here, I can write the hypotenuse. Can everybody see that? Right here, yeah, I'll make that red. So I'm gonna write right over it. Hypotenuse. I know it's kind of pinkish, but that's okay. So there's our hypotenuse right there. Now the other two, the opposite side and the adjacent side, depends on where you are in the triangle. It depends on what angle you're standing from. So what I always assume whenever I'm looking at this, so I want to solve this problem. The first step I take is I figure out where the angle is I'm starting from. I'm starting from this 48-degree angle. So I actually usually imagine myself standing at this 48-degree angle. So I'm right here. Now, from that spot, I already wrote in two different colors, but I'll point at it again. The hypotenuse is always its longest side, so that's never going to change regardless of where I'm standing. But from that spot, what side is the x side? It's the opposite side, so this is opposite of where I'm standing. So let me write that here. That's the opposite from where I'm standing. What's a 20? That's the adjacent side from where I'm standing. And adjacent just means next to. Okay? So to solve this problem, I definitely need to use those sides. Okay, I also have to remember our trig functions above. So our trig function, sine is opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is opposite over adjacent. We use SOHCAHTOA to remember this, so I'll just put a little so. This is how I memorize it. KAHTOA. So that kind of helps me remember what the order is in all my trig functions. Okay, it just means that the sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent's the opposite over adjacent. So now, when you set up any equation to solve for a right triangle, okay, the way you set up the equation is always going to be, and I'll write this right here, your trig function, so one of those above, of the angle, and this is in degrees, equals a side over a side. That's how we set up our functions. And our side is going to be the opposite adjacent or hypotenuse. So if I'm solving this problem below here, the first thing I do is find the angle that I'm starting from. So what's that? What's the measurement of the angle I'm starting from? 48 degrees. So I go 48 degrees. Now, we already figured this out, but since we are standing at that angle, which side do we want to find? The opposite side. So we want to find the opposite side x. So I'm going to say, so we want to find the opposite side x. And what's the side we already have? The adjacent side. So since we want to find the opposite, and we have the adjacent, which trig function above uses opposite and adjacent? Tangent. So we're going to use tangent of that angle. So we're going to go tan 48 equals, so I'm just following this equation right here, this procedure. So tangent 48 equals x over 20. Because tangent is opposite over adjacent, and the opposite side's x. and the adjacent side is 20. And once you have that equation, you can just solve that for x by multiplying both sides by 20. So we get 20 times tan 48 equals x. Now one thing to remember here is tan 48 is just a number. Think of tangent as kind of like, well, it's a function, but think of it kind of like as a square root function, for instance. You couldn't say, hey, let's divide both sides by square root. That doesn't work, right? Because you have to do square root of a number. So you always have to do tangent of a number. Okay, and that's just on your calculator, and just make sure you're in degree mode. So if I do that, so x equals 22.21 meters. And then the last thing I would always do is just check to make sure it makes sense. Okay, that way that will also check that you're in the right mode. If you get a negative number, obviously that's not good. If you get a number, like if I got 0.75, that doesn't make sense. Or if I got 120, that doesn't make sense. So just make sure that it makes sense that this would be 22.21, and it should make sense. Okay? So now we have two more triangles, and let's go ahead and just set up the problem first, and then solve from there. So if I'm looking at this one on the left, we'll call it number 1. Okay, my first step is to look at the angle that they're giving me. They're giving me this angle 61. So that's where I'm going to start. I'm going to start right there at the 61 degrees. So there's always a right angle because we're looking at triangles here, or right triangles here. So from the 61, what side is the x? Is it the adjacent, opposite, or hypotenuse? Adjacent. Now you got to be kind of careful for those of you who haven't been dealing with this a lot. The 15 is also the adjacent side, but it's the hypotenuse. So the hypotenuse is always set. We always know the hypotenuse is across from the right angle. That's always the hypotenuse right there. Okay, across from the right angle. So 15 is our hypotenuse. So now I look at that, I say, okay, I'm looking for the adjacent side. They gave me the hypotenuse. Which trig function up here deals with adjacent hypotenuse? Cosine. So cosine has the adjacent and hypotenuse. So I'm going to use cosine. And I always do cosine of our angle. So our angle is 61 degrees. And then from there, since cosine is adjacent over hypotenuse, adjacent side is x, hypotenuse is 15. You go x over 15 there. And I like to just do this one big calculator swoop. I'll multiply both sides by 15. So I get x equals 15 cosine 61. Make sure you're in degree mode, and what do we get for x? 7.27, and we are in centimeters. And that's it. And I'm just going to double check here. Does it make sense that this side's 15 and this side's 7.27? Yeah. We're done. Okay, so the same thing on number 2 here. That's it. Same thing on number 2 here, starting at 18. So I'm starting right here at 18. Okay. I have, what side is the x side now? Opposite. It's the opposite side from 18, right? And what about the 200? Hypotenuse. And which trig function deals with opposite hypotenuse? The sine. So we do sine of our angle 18 degrees equals x over 200. Because that hypotenuse is 200. And now we can multiply both sides by 200. Oops, ran out of room there. Times 200. And I get x equals 200 sine 18 degrees. Make sure we're in degree mode. What do we get? 61.8. 61.8. And luckily, both these triangles are drawn pretty well to scale. So it should make sense that if this is 200, that is 61.8. Questions there? So this one is slightly different because we're given two sides, and now they want you to find the angle of elevation. So they want you to actually find the angle right there. So this angle of elevation is this angle right here. And they mark it for us. So we want to find that angle in degrees. Okay, nothing really changes. We're trying to find this angle now, so that's where we start. So from that angle, what is this 20? It's hypotenuse. What's the 3? The opposite. So which trig function am I going to use? Right, sine. So we do sine of x equals 3 over 20. Now this is slightly different because, well, how do we solve that? We can't just divide both sides. This is where you have to be careful. We cannot divide both sides by sine because then that's dividing by like a square root. Or it's like saying, hey, I'm going to divide both sides by division. That doesn't make any sense. That's it. Yeah, so you use it's called the inverse sine or the arc sine, and it looks like this on your calculator. With a little -1, and it should be on your sine button, just pushing second first. So we're going to do inverse sine of 3 over 20. And again, make sure you're in degrees. And what do you get when you do that? 8.6. Degrees. And we're okay. That's it. That's it.